Welcome to lecture 11 of the CREI lecture series, the Collective for Reimagining Engineering Innovation. Today we have Professor Yoram Reich from Tel Aviv University. He has been involved in design education for a long time, as well as he spent a year at Stanford looking at the Center for Design Research. And he's an engineer who worked in the Navy and built his own first record player. So with that, I won't take too much time, and he's a very close friend, and I will let him tell the story.
Okay, thank you very much, Sab, for hosting me. I will just today tell part of a story. I will tell you about 20 years journey of designing design courses. Let's dive. So the takeaway from today's lecture are three principles. One principle is that design courses could be designed well with our own design methods. And if I summarize it, then we need to practice the principle of reflexive practice. I'll talk about it in a second. The second principle is a corollary of...
Yoram, just a second. Somebody says they cannot hear the audio. All of you can hear it?
Sir, Hello? It is audible, very clear.
Oh, okay. Thank you. Sorry about the interruption. Go ahead.
Okay. The second principle is use PSI for designing and maintaining education. PSI, which I'll mention in a second also, is a tool that Sab and I developed. And the main thing that I want to stress in this presentation in relation to PSI is focus on the team. And principle 3 is that following the first and second principle is hard but necessary, and finally it's rewarding. So first, let's briefly go into the two principles. First is the principle of reflexive practice. And basically it says, practice what we preach. We design researchers develop design tools, and we tell to others that they are great and they should use it. So we should use them ourselves in our own practice. This is that principle. The second one is PSI framework. I'll very briefly go through it, but if you want more information, then there is that paper written here, and I can provide more if you want. This is a framework for describing different design contexts that centers around three core questions. What are we doing? This is the challenge that we are trying to address. For example, designing a design course or a design program. Who is involved in designing or addressing the problem, and how those involved are working together or organized to be able to address the challenge. We call them the problem space, the social space that answers the who, and the institutional space that answers the how. And we work in three different levels: the daily operation. This is what we usually think about or act in. And then alignment or reflection. We do reflection on what we do in daily life in order to correct it. And the vision, we set up long-term visions to know where we are heading. One thing very important is the concept of alignment. You see here, but I'll show you in much better, this is the real thing. So if each cell in this matrix is a bar, then you see all of them that they are sort of connected together, I would say aligned, and even if something changes a little bit, the others set in their position right away, and this is very stable and it can hold weight. And it's in a way robust or resilient to changes in the environment. The way that it can get out from alignment is if, for example, the problem becomes much more complex. So let's increase the length of this bar, and it's not matched by an increase in the social space or the institutional space or in the tools. It will cause tearing of this rope. So if we increase something, complicate something, we need to make the other more complicated to be able to match the complexity of something else. Another view of alignment is this, but this is just partial alignment because we are aligning two things together, perhaps hierarchically, but not everything with everything else. So this is just a partial view. The concept of alignment is very important. We'll get back to it later. So the outline is basically, I'll go through 6 experiences, some in more detail. They span a sort of timeline between 2000 to where we are today, and maybe also into the future. So the first thing is just to jumpstart. I'll tell you briefly how I evolved a computer-aided design course into an engineering course. So I'll start with describing it with PSI. So here was I, YR, Yoram Reich. I was reflecting on a course, computer design course that I was teaching, and I found that really what I'm teaching is less necessary than general design skills. So I decided that I would like to modify the course, but I did not have support from, let's say, my school, my department. So while I look at the curriculum, what I decided to do basically, this was the, let's say, representing the previous curriculum, me being in the reflective layer, looked down and said, okay, I'm going to modify the curriculum bit by bit until it will change its identity. So it started as a CAD course, these horsemen black going left, and it ended up as an engineering design course, these horsemen white turning to the right, basically. Nobody noticed on the way. Finally, when I got to this place, I just modified the name of the course, and everybody didn't care much. So this was the some details about the course, the skills that I taught in the class, the tasks that I taught students to perform, tools that I taught, and the different teaching styles. By the way, I'm not going into all the details, but I gave Sab the slides. Perhaps Sab, you can post in the chat, or I can send it later to everybody, so you can have the more details. And for some of these things, there are papers that describe them in much more details. But this was just a sort of a story. A much more important example is a systematic design of a robot design course, which took place between, let's say, 2002 and 2005. So again, using PSI, a friend of mine with whom I did my undergraduate, his name is Eli Kohlberg, he wanted to do a PhD, and he had some experiences with some advisors, but they didn't work out so well. So at some point he talked to me, and we sort of reflected on what happened. And I asked him, okay, so tell me more about some of the things that you are doing. And he said that he is teaching a robotic course in a high school, and he has some issues in the course. For example, the robots that the student develop and produce are not robust enough. And there were some other issues that he wanted to improve. So I told him, okay, fine. Seeing your vision or what you want to do and some of the difficulties that you had with advisor, let's make this the topic of your thesis. And if you want, I can be your advisor. Okay, so let's cross this PSI. It served its purpose. We are now moved to another PSI. Now here at the bottom, this represents what Eli Kohlberg course was. Okay, so he was designing, teaching students to design and implement and test robots. And our idea was now, let's design, implement, and test a successful robot design course. Okay, so we wanted to create an impact. This was our vision. And now our task was basically to do this. This was Eli's Kohlberg task. And our task was to occasionally meet and see how it goes, basically. So here is the process of designing a course. It's quite simple. You start with the needs, translate them to requirements, come up with the means to address the requirements. From that, develop product and implement the product, deploy, test, and reflect upon it, and then can cycle and improve it and so forth. So this is what we basically did for that course. We looked at what designers do. Some stuff from this basically came from studies that actually Sab did before at Carnegie Mellon in his research, and some from new research that was available. We also looked at the needs for future design environments. Okay, not just what they do today, but what they might need in the future. Oops, I had some. Okay, so for example, what we know that what engineers do, they spend a lot of their time seeking, organizing, modifying information, not just doing what we think of as engineering. We know that engineers make a lot of mistakes. They generate bad concepts, for example, the Concorde or this Volkswagen compared to the new Volkswagen and the Jumbo. So engineers create many times bad concepts. They have tough time to translate trivial requirements to designs, and they fail. And really, the majority of products developed yearly in the US and elsewhere fail. And this is because they don't practice properly design processes. So it was clear to us that we need to teach proper design processes, which were not taught in the class before. And we also looked at the changing world, what might be some of the challenges faced by future engineers. This was done in 2006. The same challenges are discussed today. So really, the idea was not just have students design better robots, but also develop their skills for the future. Then we had to translate the need to requirements. One can do it with tools like QFD. I won't go into it here. But I'll briefly mention some of the requirements that we came up with. For example, we want students to have basic personality skills, design-related skills that we want to teach. For example, how to do synthesis, how to foresee interactions, how to make decisions, social skills that we want students to have, or any engineers. Of course, we wanted to know facts and methods relevant to the design subject matter, for example, robotics, mechatronics, and so forth. But this is trivial. I mean, the other things are critically important. Basic management skills, time management, other resources, and system thinking skills. Really, if you look at what people think today about the requirements of the future skills of engineers, these things cover everything. So nothing has changed in the last, I would say, almost 20 years, in spite of the fact that people come back and rediscover these necessary skills. Okay, the next thing is to go from requirements and to find means. So in order to do that, we need to dive into a particular example, which is the robotics course. So let's go on. Now, the diagram is slightly different, but it's the same thing: needs, requirements, means, product, and then implementation. Okay, so we want to go through these, and there is a paper here from 2014 that basically describe everything that I'm going to speak now, and it will refer to other papers that are listed here. If you ask me, I'll send you later. Coming back to the principle of reflexive practice, these are the design methods that we use to design the course. So of course, we use brainstorming, conceptual modeling. We did failure analysis of previous design products that were developed in the courses in order to come up with issues that we need to improve the course itself. We did function means tree to go from the requirements to the means. We did quality function deployment to come up with priorities about design methods. We prioritize them using AHP, so we have basically a way to decide how much effort we are going to spend on each topic in the course. And then we did failure mode and effect analysis, asking how these methods that we agree to include in the course may fail because they might be used by students. And then we did prototyping. So I'll go briefly on each of these now. You see these methods that we use spread out across the design process of the course. So these were the skills. We talked about them, so I'm jumping here. From those, we identified the skills that are necessary. So, for example, system skills, learning, self-learning, creative thinking, time and budget restriction or time budget management, teamwork, and so forth. Perception of technology. This was something that, since they were high school students, we wanted to increase their perception of technology to guide them to study engineering. And interestingly, we wanted also to improve their science grades. I'll come back to this interesting point later. So these were the desired skills. Okay, so we have these skills and then course goals. This was sort of almost a direct translation. And then from those, we sort of came up with some course topics that we wanted to include in the course. These were the learning activities that we thought basically that are available to us. We had to pick from them or to match them to these principles. Some of the problems that we identified from previous courses or previous robot are listed here, and we came up with solutions. We need to teach conceptual design. We need to teach fault tolerant, to adapt the method to the student level, to make students use the methodology that will teach them. Fuzzy logic control is necessary, and some other topics like, for example, ACID is creativity, ATRs is how to handle the requirements well, and microprogramming design for designing for control. This is a QFD matrix where we looked at the issues that we came up in previous courses here. These problems that we wanted to address. And here, the topics that we thought we should teach, and yes. So these are the topics that, and in this using QFD, we basically prioritize the methods, and this helps us decide what is going in and out. So the things that got very little ranking didn't got in. So for example, ergonomic design was not so relevant for us as a robotics course class. And also detailed design, we didn't think it was important, although clearly it's an important topic, but it didn't present much opportunity to address the issues that we raised. So the method that we selected to concentrate on were these 6 methods. And when we looked at those, we understand that the 2 of us, Eli and myself, didn't have a knowledge or sufficient expertise in the ATR and the microprogramming. So we brought another professor, Ilya Levin, to be a sort of co-advisor to Eli. So you see here the need to align this PSI when the problem is getting more complicated. So in this way, we aligned it and we were able to address all these topics in the class. Then we did, ranking based on AHP. So we got all the methods, and this is the relative ranking of the different methods. So we understood that we should concentrate significantly on conceptual design, fault tolerance about half of the time, and there are other 3 topics, 40%, divided somehow between them. So this got translated then into the number of hours covered in the course for these topics. Then we look.
Yoram, can you just say what HP is? Probably people don't know.
What?
What AHP is? Just expand AHP.
Analytic hierarchy process. It's a decision-making tool developed by Sati at the 60s of the previous century. It's being used a lot by many. It's excellent for prioritizing and selecting. It has some built-in facility to evaluate the consistency, and this is why it's extremely well used in very diverse problems. Then we looked at how the problem that we selected here can fail. So, for example, fuzzy logic. I mean, it includes mathematics. Students might not understand what's going on. So we for example, for the fuzzy logic, we eliminated the complex mathematics and found out a way to teach it in a straightforward manner. And this is in the same way we sort of simplify the other method as well, so that they fit the student levels. Okay, I'll jump here. This is in more detail what we did. Another method that we wanted to test is SOS. This is an interesting method that was developed by a PhD student of mine, and it's about developing optimal product concepts or system architecture. So it was quite complex, and we didn't know if we wanted to teach it to students or not. So what we did is we prototype the method on the topic of designing robots. So Eli, this is Eli, was explaining the problem, some problem of the robot. We started with the rules of the competition that for which the students developed the robots, and Amir tried to see how to address the problem, and it got complicated, and we basically skipped this. So something that we are not certain, we prototype, and that method we rejected. Another one we also rejected because it was too complicated, and we also prototyped the course itself. So all these methods basically got translated into very detailed curriculum week by week of what we actually do. Next thing what we did is we wanted to test it. So we are now at the phase of where here we test the so Eli was sitting in 4 schools. One school got the full system, the full curriculum, another school less, third less, the fourth one didn't get any, but they got something else in between to fill the hours. Okay, so we cannot, nobody can object to the process, saying that we taught these people, the students, less time. We taught them some other things, but not as well as we taught these. So interestingly, grade in mathematics, improvement of 5.7 for school A and 1.8 for school D. Now, remember, these are excellent high school students that takes the highest grade of mathematics and physics, and they take extra in robotics. Yet, just by studying design methods and this curriculum help improve their grades in mathematics and similarly in physics and chemistry. I think that this is fantastic because it's sort of reverse logic. We usually think that if we improve mathematics and physics, then we would get better designs. So it's reverse, or it operates also in a reverse way if it's done properly. Now I have to show you the competition because it's fun to see. This is the competition, and there is a candle. The robot does not follow the candle. Finds it extremely difficult and it gets close to your back. This is the robot that won first place. And if it competed against university students, the bronze was the time the same. Same shoe, just different just to see the student is sufficient. Okay, so what we basically gained is that now robots that were designed were robust. So this robot made it 3 times in 3 trials, got the best results. So it's not a matter of chance, something like this. It is designed well and it's performing well. This is just to show that after this was the pilot study and then the full comparative study of the 4 schools. The school that had the full curriculum got first prize. The school that had 3 or the third curriculum got 6th prize. The one with the 2nd and 4th didn't get into the competition. So we don't have data, but the next year, Eli transferred the curriculum to other teachers and we got 1 to 3rd prize and 1 to 4th. We understood that this competition is becoming irrelevant to us. So following years, teachers other than Eli started to go to RoboCup, dancing or other types of competitions. And at the years that the teachers that practiced the curriculum participated, they won first prizes. So, I mean, we can really say that it's sort of consistent result. To reflect design courses could be designed. It's enormous effort to generate and maintain and align PSI in this manner. And the opportunity, I mean, I was able to carry out this, for me, magnificent experience because Eli wanted to do a PhD. So it's opportunity that was basically realized. A short journey into designing engineering programs. If you're not familiar with CDIO, go to CDIO.org. It's an organization formed by MIT, Chalmers, Linköping, Royal Institute of Technology in 2000 to revitalize engineering education. Many more than, I think, 200 universities participate. I started with a colleague, Melanie Samson, at about 2010, not-for-profit company to do revitalize engineering education in Israel. Again, it was opportunity-driven. Melanie left her work, wanted to do something, and I joined. I'll later comment on some of these opportunities. Sometimes they go well, sometimes not. This one, for example, lived short because we couldn't keep up with the salary that we needed to pay Melanie because she was doing it full time. I was volunteering, but she needed to get paid, and it made our operations quite expensive, and we couldn't keep up with that. So I can talk about the PSI, but it was clearly misaligned. We had no budget, although we wanted to secure it, but it didn't work. We actually ran workshops all over Israel, and we talked to deans, presidents of colleges. In two colleges, we ran serious workshops with the faculty about designing curriculum. Two of them, I mean, those that we conducted workshops actually continued work on that, and actually are quite advanced in this. Some of the pictures, but essentially what this does is we have stakeholders. This can be industry, students, faculty members, parents, whomever you want to include, and think about what might be the goals or requirements of an educational program. An educational program is something that takes on high school graduates, however they come from the high school education program in Israel or elsewhere, and we want to get engineers or researchers with those particular skills and knowledge that we like, and we need to configure the program. So this is exactly what we are talking, right? Just that now we are speaking not about a course, but about a complete curriculum of a program. And then we need to test whether we actually achieve that. And the way to do it is we think about the learning outcome that may be skills, capabilities, knowledge, whatever you want to have here. And each of these need to be developed gradually along the course of the curriculum as it progresses. We don't need to change all courses, just some of them, and do it gradually. So, for example, for learning outcome 3, we start low, increase, and until we get to where we want. So this is the way to develop a curriculum in a systematic way. Yeah, so too much opportunism basically is not sustainable. So we in this operation, we had to generate significant amount of budget or resources upfront, because otherwise it cannot be sustained. And this is true, I would say, for any engineering program. When we start such an adventure, I mean, it was me, let's say in this case, Melanie, and even in the robotics course, it was Eli and me. But when Eli left, he had to teach other teachers the methodology, and not all of them got the whole thing. And when they left, basically today, nobody teaching this approach anymore. So basically, after several years, if you don't train the leaders and keep maintaining the leaders sort of in the community, the benefits evaporates. Another point is higher education institutions are extremely conservative. Although they think that they are innovative, they are indeed conservatives. Let's jump start into where we are today, or how we got here today. So I left you with the engineering design course that I evolved from the CAD course, and then at some point I was approached by people from the unit for social development at the university. They wanted to create courses with social impact, and my vision to make capable citizens, to basically generate people who can contribute much better to their society. And let's say for me, and I would say for Sub, better citizens is congruent with having design skills, basically, and go read the book that we wrote, We Are Not Users, Dialogue, Diversity, and Design. It talks much more about it. So we basically, this was sort of a quite aligned course. We have the resources, we have the budget, we have the people involved, the unit for social involvement is basically bringing resources and people, so we can actually run this today for I think 6 or 7 years. The way that we moved the initial engineering design course, which is a regular engineering design course, to where we are today, is we moved frontal teaching to flipped class. Students are supposed to look at videos at home and come back to class and then just work with mentors. I was teaching with a TA, now it's lecturer, me, and 3 to 5 mentors and course administrator. Students, I used to have the course with about 100 to 120 students working at home in groups. Now it's 90, and we were also 150 students working in team of 5, 6 students with 3 to 5 mentors. All of this happening in parallel. And you can imagine just finding 5 classes at the university at the same time is a problem. So it boils down to very mundane issues if you want to run such a course. The challenges also got different here. It was specific challenges that the students brought up. Here it's social, environmental challenges designed by the team. It basically makes students work on really wicked challenges. They dislike it, they hate it, they don't know what to do, but at the end, they thank us for getting them through this experience. The course beyond cannot scale up to more than 150, so I can really do not attain my vision of basically educating what I want, all the students at the university. It's impossible to deliver value to stakeholders in 1 semester, so we need to come up with new ways to do something. And it's difficult to create true change in students in a single course. Now, recall that the CDIO or IEI approach that I showed before tells us that we need to develop such skills in 3 or 4 years curriculum. So anyway, this is how we stand today. This is the last lecture. I asked students if they want to change some more in the last minutes. I asked them to come and if I didn't run away. And we were willing to do so. Let's stop this. I'll briefly go into 2 or 3 experiences just to show you the sort of the diversity. This was a course that we call Design with 5 Voices. It started again with fantasy of somebody, an architect, and the manager of the unit for social involvement, and they approached me. They thought that I would say yes, and indeed they were right. I said yes, and we got a few other people. So actually, this was a course, design course. The task was to design spaces for the Center for the Blind in Israel. And students in the class were from architecture, from mechanical engineering, social work, occupational therapy, and stage design. Quite a diverse 1-year course, 3 hours engagement per week. And COVID hits at the middle of the course after the first semester. Yet we sort of managed to complete somehow some delivery to that center. But for example, some of the issues that we had to think about, for example, what is an assignment? The students from these different 5 programs all had different idea of what the word assignment means, and different idea of what presentation mean. And each of us had a different idea of how you grade students. So this was quite a challenging task, even for us, because we had to align our perception I'm talking about the teachers, align the concepts. And in order to do this, we have to leave ego aside. Now, again, the teachers, to coordinate the teaching material between instructors, and the complete operation must be streamlined. It was extremely expensive. This is part of the reason that it only happened once and not repeated again. I'll skip this. I'll skip this also. And another experience was taking the ideas of the yes, here I'm you don't hear the voice because it's in Hebrew. So I was teaching a class, and again with the unit for social involvement, with whom I work a lot, and the head of the MBA innovation program at the university, and also the head of the innovation in the Tel Aviv municipality. In the class, we had MBA executive students and employees of Tel Aviv municipality working together, basically studying the course together and working together on challenges that were given by the municipality. But it was too short, very few hours a week, and the students were sort of executive MBAs, not used to work too hard. So I mean, we managed to basically develop proposals for the municipality, and one got 150,000 new Israeli shekels to actually continue work on that. But again, it's not a sustainable operation. So you see, here I'm acting as somebody from India, basically presenting different cultures and its input into how design should look like from that perspective. So it's very, very important to capture all these experiences, and basically, if I use PSI, let's say, I think that I can now tell where something like this would work and where it might fail in the future, and in order to, I don't know, guarantee, but improve the success ratio of such courses. The future, for example, so one of the people now is Doron Tsuri, is a new PhD student and is doing research on the course. Necessary item because we want to really understand what works and what not. For example, we now have a challenge because the administrator of the course is leaving, and basically in a meeting this week, Doron told me, well, shouldn't we now use our tools, I argue, to address this problem? And I said, sure. And we now need to basically realign the matrix to make sure that the tasks that the administrator is responsible and her skills can be captured by somebody else or some other functionality. The fantasy is basically break down the teaching material into really small atoms, like problem formulation, alternative generation. Okay, somebody's selection, risk management, theory, basically to very simple and small topics, so that other faculty members or lecturers can decide which item they want to introduce in their class, in their PBL class, for example, and basically be able to take only those items and into their classes. So this is my fantasy. It requires training teachers, mentors in the methods, in the approach, preparing training, testing material, prepare administrators for the courses. So there's a lot of basically social space or capabilities that we need to generate in order to align what we want to do I mean, the challenge with what we have today. And actually, I'm looking for partners to try to do things like this elsewhere also. Summary, principles again. Don't invent the wheel. I mean, if you want to introduce something like this, then look for other experiences. Certainly, if you are developing programs, look at CDIO. If not, look at other courses in the design. Make sure to have sufficient resources. It's people, budget, even classes. I mentioned that it can be. I mean, I didn't believe this would be an issue, but it turned out to be a very critical issue. Not only just classes, but classes that teams can spread out and work comfortably, and management support from the university or the faculty, and make sure that whatever you do fits the student character, because otherwise, if there is no match, it will fail. Basically, in my language, it won't be aligned. Okay, I need to thank all these people. And with that, I end my presentation and thank you for your attention.
Thank you very much, Yoram, for this really grand tour. Every time you give this lecture, I realize you tell me more than the last time. With that, I will open it up for questions. Please unmute yourself one at a time or raise your hand so that we can call on you. Sudhir, you want to go first?
Yeah. Thanks, Yoram, for sharing your entire journey of developing a variety of design courses. A lot of issues that you have pointed out, I think we can relate to it. The one challenge we continuously see is, especially when you want to develop a new course or a new program, right? You may not have all the resources available, and it's always a kind of chicken and egg scenarios that you will encounter. And somewhere when if you look for all the resources and the alignment, things may not even move forward, right? And somewhere we have to take the risk and put something forward and then look for the resources. So this challenge constantly is there in many of the programs that we look at. Any thoughts on how to break this, or how to make this judgment? When do we think when we can actually take a risk and go with the problem and then address the other elements later?
First, this is why I started with mentioning the initial experience. Take an existing course, modifying the curriculum bit by bit until I got the final engineering design course with the resources that I had. Even then, it was not so easy because when I introduced it, I didn't have a TA that went through that process. So even this way, it sometimes can be difficult. Okay, so the thing is, we have to really think about all the potential issues that might be involved. So you can do that, but there is sort of a limit to where you can go. So this is why I didn't do anything with that class for a number of years until the opportunity came with that unit for social involvement. I mean, they brought the resources for mentors that I didn't have money, and it was clear to me that I wouldn't get money from my faculty, because this is bringing 3 mentors instead of 1 TA is a huge additional budget. So until that opportunity arose, it wasn't impossible. And unfortunately for us, I don't know your experience, but my experience is that in some places, design is not considered a serious enough topic to teach. It's not hardcore engineering. It's not theory. You learn it in industry. How incorrect. I mean, industry failed. This is why I mentioned the sort of 25,000. This is a statistic from way before, and I don't think it's better today. All these failures because of not practicing proper engineering tools, but sort of doing stuff intuitively, running fast forward from thinking about what might be the needs, but not confirming actually the needs or the requirements, and then going fast forward into a single solution, developing it, and then seeing that it's not the best one, it's not even addressing the needs, and so forth. So industry is not a place to learn design. University, good design courses is the place to learn design. There is theory in teaching design. It's not just practice. But we are still looked down from people who do basic science. And this is a big challenge. I don't know in your case, but to me, it's a big challenge, getting resources.
Thank you.
There is somebody who has put a note. I hope he will talk. Says, thank you for the lecture. We have had exactly the same experiences in India. Industrial design schools in India have had better experiences using similar methodology you shared. Engineering courses are resisting such any such experiment in teaching. Mr. Pradeep, you want to speak up? Okay, you can answer the question while he decides whether he wants to join in. Yeah. Yoram, you can.
Yeah, he is basically saying that he has a similar experience. So I'm not sure what is the question.
Oh, I think he's just saying that in the Indian context, the resistance is more in the engineering side, but some of what you are practicing is there in the industrial design side, but the two don't meet in a sense in the same way as well, I think.
Yeah.
And you have similar problems in Israel as well, right?
Yeah. I think the statistics that I mentioned basically tell that it's all over the place. It's not just Israel, India. I think I'll tell you something personal, okay? I was meeting Doron, as I said before. This
and just made a comment.
Yes, please.
See, the canons of knowledge and the methods we have employed since the beginning somehow put us into clear containers or categories, so much so that some of the creative and other methods the professors just shared have been developed in engineering itself, but more used by industrial designers or product designers or graphic designers, as you call them, schools of design. Whereas these methods are, unfortunately, when we try it out in curriculum in Indian engineering, there seems to be a little resistance saying, okay, there is nothing, no mathematics in it, there is nothing. How can anybody land up designing such a thing following these methods? This is, a big issue with us here. We don't have time left. I'm sure Professor Yoram will agree, and he has been reflecting it in his slides, saying, there is nobody else to now carry on this experiment further. This is one of the issues that I empathize with him. But it's very interesting. One question that I have had is, just for clarification, who are the students that teach? See, for us, we always take students at an undergraduate engineering or postgraduate engineering program. I saw in your slides you are addressing students. Is it school? Did you hold these courses for school level students or
No.
for engineering?
No. The robotics class was for high school students. The rest are, well, not the rest are for engineering. I mean, engineering schools. Except that I also mentioned one that was for MBA, so Masters in Management students and the employees of Tel Aviv municipality. So diverse, and also the course with the 5 voices, engineers, but architects, social work, in occupational therapy and stage design. So very different audiences. I don't think this is. I really think that the skill of taking a very broad problem, for example, address food security issue, address water scarcity, as we pose it to students, is something that everybody must be able to at least start thinking about and address. And this is how we start some of these courses, and the students have to basically study this topic, understand what are the issues, select a particular topic on which they want to learn in the course, or to deal with in the course of the class, which lasts for 13 weeks. So they have to match their interest and importance of problem to the time they have, to their knowledge. They have to align all these things, and then they select a particular problem and they go after it. Again, by diving further in to understand the particular problem that they selected. I think that these skills are important for engineers and other professionals and citizens. I mean, you want to think about your career. It's sort of an open-ended question. How do you approach it? If you do it intuitively, fine. But if you have tools and way to think about it, then you do it, I think, in a slightly better way. And this is what I want to achieve, basically, at the end.
Agree with you, with your experiences. Thank you.
Thank you. Any other questions from anybody else? Any clarifications, thoughts? Or you're all frightened by the task that is required to achieve something like this? I think all of that are genuine in the sense that this is not, even with some kind of institutional support, Yoram was able to do several things. Without institutional support and attitude to these things, it's very, very hard. And you can see that everywhere. Many experiments have taken place. Some of them have succeeded, some of them have not. And really, our goal at CREI is to bring all of these experiences from around the world, because it is a struggle, I think, not only for India, but as we saw in the last lecture with Jörg Schulz, it's a struggle in Germany to integrate practical and theoretical pieces of engineering and social pieces of engineering. And we hope that we will continue bringing these lectures, and we have already allocated 3 more lectures. We will take a hiatus till August 9th, and the next lecture will be by Professor Amarjit Ramnath, I think. He will be giving a lecture on history of engineering profession in India. So, and there are 2 other lectures. We will announce them in the web page. Unless Sudhir, you want to mention them, who they are and what their topic might be, please.
Yeah, the one on August 23rd will be by Professor Ramesh Babu from IIT Madras. He will speak about the Center for Machine Tools that they have set up for a period of time, looking at both addressing the needs of companies as well as competency development and research and manufacturing. And I think also indigenized some of the manufacturing things. So that will be on 23rd August. And then the next one will be on 6th September by Dr. Bhuvaneshwar, who will speak about the medical device. He has been involved in the Chitra, which is in the market.
Announce, yeah. We will announce them. Your voice was a little bit muffled, Sudhir, earlier. Anyway, we will announce them in the, pardon?
No, my internet may be a problem. Yeah.
Yeah, that's okay. Anyway, we will announce them on the webpage, CREI webpage. And thank you all for coming. And I hope you will continue to attend these lectures. And as I had mentioned earlier, if any of you have any experience of doing this kind of experiments, please contact us. We would be very happy to have you present your experiences, because this is a place for us to share experiences so that we can all do better. Thank you. Thank you, Yoram.
Thank you.
Yeah. Thank you. Bye.
Thank you, sir. Thank you very much.
Thank you.
Okay, I'll see you. Okay.
Bye.
I want to stop record.